We started looking at statistics yesterday. I'm going to continue with that. We looked at two different types of variables, right, data. They break into categorical data, and that's data that is things like colours and countries and so on. And that is then broken into two subgroups. You're either ordinal, which means that there's a sensible order that you can put things in, and alphabetical doesn't count. Right, so an example of something that was ordinal could be, what was the one I did, the high school one, right? Like the sophomore, freshman, junior, senior, right? That would be a natural order. Not ordinal is much more common. Things like countries, right? You know, what country have you been to, or what country do you want to go to? You know, Germany, France, Peru, whatever. Those would count as not ordinal because there's no natural order, and alphabetical doesn't count. And so that's categorical data, right? Categorical information is you collected information and the answers that you got were things, were words, and then you counted how many. In the quantitative world, your data that you collect is numbers. In that sense, then we have, well, there are two subgroups. One's called continuous and the other's called not continuous. Hey, teaching here. My dog's joining in. So, not continuous would be things like how many children in your family, right? Number of coins, how many toes you've got, right? Whatever. Things that can only take fixed values, right? You can only have 1, 2, 3, 4. It is not sensible to talk about, you know, 1.5 coins in my pocket, right? That type of thing. And we call that type of data not continuous. And numbers that are continuous are things where you can take all the values between any two numbers, right? Theoretically, at least. So things like people's height and weight would count, right? Are we comfortable with those definitions, right? So let's just spend a few moments looking at some more homework questions. And then we'll get to some new concepts after that.
Yeah, I was doing the homework yesterday and I ran into explanatory and response variable
and you stopped because we haven't done that yet, and that's actually going to be the next topic after this. So okay. You'll be good.
And I was reading it through the homework, the README link, and I couldn't find it.
Oh, they must have hidden it well. So randomly just picking a question here just to show you what the homework questions look like. So for each of the following, indicate whether it's ordinal or not. So you'll say it's ordinal or it's not ordinal. And if it's not ordinal, indicate its variable type. So if I went, if the data that was being collected was an opinion about a new tax law, and the people said, yeah, I like it, or no, I hate it, that would be their answer. She'd get it right. Yes, no, favor, don't favor. This is ordinal. Sorry, this is, yeah, no, I clicked on that one. Would you agree this variable is ordinal? Or is it not ordinal? But it's still categorical. What do you think you would do if there's only two answers, one's favour and the other's oppose? Can you put them in an order?
It's not ordered.
No, I don't think you can. If there's only two things, just like we have a rule, alphabetical doesn't count, right? If there's only two things, it doesn't count, right? That was a weird one. Okay, how about grade letters, right? So you got an A, a B, a C, a D, an F, and you know, whatever, right? Would you agree that that variable is ordinal? It's categorical, right? Because it's an A, B, C. And isn't that got a natural order? Isn't an A the best grade, a B the next, and a C? So you might say I'm breaking my alphabetic rule, but I'm not really. Right, if you had the height of people, Well, if you're talking about the height of people, isn't it the third dot? It's not ordinal, it's quantitative. Isn't ordinal only used for things that are categorical that can be put in order, right? It doesn't mean everything. It just means only things that are categorical. The number of coins in your pocket, continuous or not continuous?
Not continuous.
Correct. You can only have 4 coins or 5 coins. It doesn't make sense. And that's us finished with that. So, just like you said, what's this new fella called? Well, explanatory and response variables. So in these situations, what you're doing is you're collecting information. Essentially, you're collecting 2 pieces of information. And then you're seeing if there's a connection between them. And I like to visualize it like an axis. So one piece of information goes along the x-axis, and the other piece of information goes along the y-axis. So for instance, suppose I collected the ages of children and their weights. So I'm collecting 2 pieces of information, right? Ages and their weights. Along here, I might put their ages, and vertically I put their weights. And can you imagine then for each child, you know, some child was 7 and they weighed that, another child was 8 and they weighed that, and another one was another child weighed, well, was 8.5 and weighed that, right? And so on and so forth. Now, if you collected, each one of these dots is meant to be one child, right? So, you know, that child there might be 9 and 3 months old, right? And that would be their weight. When you collect 2 sets of data that are connected in such a way, one of them is called the explanatory variable, and the other one is called the response variable. The explanatory variable is the one that you would put on the x-axis. And the response variable you would put on the y-axis. So if I collected the age of children and their weights, their age would be the explanatory and their response, right, would be their weight. Think of it like this. Would the major reason a child is the weight he or she is be their age? In other words, wouldn't a 12-year-old typically weigh more than a 9-year-old, which would weigh more than a 3-year-old, right? So the explanatory variable is the variable that is really explaining what you're measuring, right? You're measuring weight, but what's the main reason for that weight happening? Well, it's their age, isn't it? Right? You see, there's a kind of one is the main reason for the other. Right? Try an example of, suppose you collected data on the number of hours a student studied before a final exam and the grade they got in that final exam. Right, so the x-axis was how many hours they studied and the y-axis was their grade. The explanatory variable would be how many hours they studied, right? And the response variable would be the grade they got, right? So the more you study, we're assuming the better your grade, right? You see the connection. Something is explaining, explanatory, why the other one is what it is. Does that make sense, that description of explanatory and response? So here is a pair of variables. I'm going to go back. It's just easier for me to use their questions because if I just read it out, for some reason it doesn't stick in my edits. For each pair of variables, specify the variable that's the explanatory one and then which is the response one. So the score that you got in the final exam and the final course grade in your psychology, right? Explanatory, final grade. Would you agree? if you got really good final, wouldn't have a good effect on your final grade. If you did really bad, wouldn't have a really bad effect on your final grade. Now, I can imagine that if you phrase that question the other way around, couldn't they switch places? So you got to be a little bit careful about that. But normally, isn't the first thing the explanatory and the second thing the response, at least in most cases. Now, just to show you that they can play with your head a little bit, the opinion about the death penalty, arguing in favour or against, and male and female. So we have got to decide here which one of them is explaining the other. Right. So I'm going to go and switch the order here. I think being a male or a female is going to be the main reason you are for or against the death penalty. So if you do what I just said, you would do that one. Now, the good news about these homework is because you get 5 guesses, if you got that one wrong, couldn't you pick the other one? There are going to be, I guarantee, because I already have done it myself and I've done these questions, there are going to be some questions I'm going to disagree with them. I'm going to say, nah, I would switch the order. I think this is explanatory and that's the response, right? Because there could be a little bit of a judgment call. Would you agree? That in some cases you might think this is the reason it's happening, right? This is explaining it, and the other one is the response.
So is the explanatory variable, is it dependent on just the variable you think explains it, or is it the one?
Hopefully one is more obvious than the other, right?
Just thinking in stuff like, say, I know a study of alcohol consumption and depressive score index, something
right.
where there's.
So if you were doing that, you could say, I would say anyway, that the explanatory was how much alcohol. Excuse me. I think I'm going to have to. There we go. The joys of teaching online. Right, back to your one. I could argue both directions, but me personally, I would think the x-axis is alcohol consumption and the y-axis would be the depression one, right? Index. Now, could you switch them around? I bet you could. Would you be able to get, I guess you have to say, is drinking alcohol making you depressed, or is it because I'm depressed I drink more alcohol? You see that you can phrase it both ways. So that would be a good example, I think, of, now I'm thinking about it, couldn't you switch them and it wouldn't really be wrong? It'd just be a different interpretation. Normally the one that you can actually change or control is the explanatory one in science. So I can change how much alcohol you can drink if I was doing the experiment. Couldn't I get 100 people and make one of them drink only 1 glass of whiskey and some of them drink 10 glasses of whiskey and then ask them how depressed they felt, right? That would be one way of separating them. I can't make people depressed and then find out how much they drink. That way around is immoral, even if the first one isn't.
Excuse me, I forgot what you said yesterday. Is the homework timed or not?
Homework is not timed. You have as much time as you want to do the homework.
Okay.
I'm looking for some others of these explanatory ones. Okay, here is question 11. I'm not quite sure what we're looking at here. So let me make sure that we are looking at the questions. Oh, we were. Okay. Is the average IQ of a left-handed person higher than the average IQ of a right-handed person? So the explanatory variable is whether they're left or right-handed. And that happens to be categorical. Would it be ordinal? Left and right. Could you put that in any? I wouldn't. I'd say categorical.
I mean, I say, I mean, if you want to get into physics, technically, but No.
Let's not then.
Yeah.
But
that's-
It's not left first, right second, or right first, left second. So it's-
Yeah. So, yeah. The response variable then is the IQ of that individual. And the IQ is, an IQ of 100, 110 isn't an IQ actually a quantitative variable. Does that make sense? So we're looking at the average IQ of a left or right-handed person, and we want to kind of put this whole package together, and we're basically filling in the missing phrases. So the explanatory variable is whether they're left or right-handed, because does that make your IQ different? Right? It's being left-handed people got a higher or lower IQ, so that's how I'm reading that. That is a categorical variable. And the response one was what their IQ is, and that's a number, so that's quantitative. Okay. For married couples, is there a relationship between owning pets and whether or not they get divorced? Now, when they phrase the question this way, you can pretty much see that that comes first and that comes second. So the explanatory variable is which one? Well, let's say it's whether the couple own a pet, which is a categorical. And the response is whether they get divorced, which is also categorical. Now, if I got that back to front, it's easy to switch places. That's another one. Okay, stop. So just in kind of summary, there are two variables going on in these stories. And one of them is the explanatory variable, one is the response. The one that you think is causing the other is your explanatory variable. And there may well be some gray areas where you switch places. But as many times as possible, try and think of the x-axis and the y-axis, or think of this is causing that. And the x-axis, or this is causing, is going to be your explanatory variable. And what happens, right, the response, think of that as being the y-axis being your response variable. Any questions about that before we move on? Okay. Now, we are going to be looking at data, and it's being collected and summarized in the form of a table. And so I'm going to do an example of that. Let's suppose I collected data, and here's my little data. Look something like that. And we asked people, have they ever broken the speed limit on a motorway, right? An I route, an interstate route. Have they broken the speed limit? And the answers we got are, I've never done it. The next answer is that I sometimes do it. The next one I'm picking is that I mostly do it. And the last one is that I always do it. And so the second one is called the frequency. So you went and collected a nice random sample and you asked people, have you ever broken the speed limit when you drive on the interstate? And 3 people said, I've never done it in my life. And 2 people say, I always do it. They're going to be 15 of them says that. 30 of them says that. I'm making these numbers up. Which is probably true in Scotland. Scotland, the speed limit on motorways is 70 miles an hour. That's the fastest you can legally go anywhere on open roads. And that's on what we call on motorways. If you ever drive in Scotland on a motorway, virtually nobody does 70. 70 is the start number. Most people on a motorway drive about 80, 85, and nobody gets a speeding ticket unless it's one of those cameras on the bridges, and they only do that to get money off you, right? Because it's all done automatically.
Do they have that, is it like in, I have a lot of relatives from Appalachia. Is it like there where you'll sometimes then end up with roads with a ton of crosses on them or something?
No, no.
Okay.
They just don't have speed limit. Well, they do have a speed limit, but they are infrequently called. So if you ask a person in Scotland, did you stick to the speed limit on their thing? You would find a lot more people who say, yeah, mostly I do it. Yeah. Some will probably say, I always drive faster than the speed limit. You know, speed limit is just a starting number for some people in Scotland. So what you're going to do now is we're going to look at this summarized data, and I'm going to add it up. Hopefully I got the numbers right. And it comes up to a nice round number of 50. And you could be asked a lot of questions from this table. You could be asked, for instance, things like, what percentage of people most of the time break the speed limit? Well, you know how you get percentage? 30 people out of 50. Wouldn't that be the fraction of people who mostly beat the speed limit? Right? But if you want to make something into percentage, don't you then take the 30 out of 50 and you multiply it by 100? And the answer I get is 60%. Are you comfortable about the calculation I used there? Okay, 30 out of a total of 50 times 100. 60% of the people said they mostly would break the speed limit. Right? And so you could take all of these guys and turn them into percentages. For instance, this one, I'll use green, would end up being 6%. And this one would end up being 30%. This one we just did a moment ago is 60%. And this one would end up being 4%. So if I asked you to find out what percentage of our sample did any of these, isn't this the calculation that we use? That seems reasonable. What would be a good check that these answers were correct? How could I simply check that I did it? What could I do?
Add the percents.
And if you did it correctly, shouldn't you get 100%? Does that make sense? Now, sometimes the numbers don't come out as pretty as the answers I've got, right? 4s and 60s. So you might have to do a little rounding off to 1 decimal place. And if you do that, this might not be exactly 100. It might be 99.8 or 100.1. And that's okay if it is, because that's probably just an example of rounding off.
If you look at most polls, usually they'll have a little disclaimer which says the results may not add up to 100% due to rounding.
Yeah, that's exactly what I'm talking about. Yeah. So if you ever see that and people say, well, what happened? How come there's 100.2% people voted? And they say, see, cheat, lie, some bad happened. No, it's just they rounded things off, right? And, things go a little bit more. Now, we have a name for when you take data. This is a frequency table when it looks like this. But when you take data and you turn it into percentages, so what percentage of your sample did this? And the name that you're going to see is called a relative frequency. Relative frequency. Now, relative frequencies are percentages, or you can also get them as decimals. So in some situations, the relative frequency that you calculate will be in a decimal.
You do a single frequency divided by the total times 100, and then that will get you your percent.
Correct. And if you don't do the times 100 part, you'll get the decimal answer, which is also called a relative frequency. So you'll know in the question whether they want you to do the percentage answer or the decimal answer, because if they want the percentage answer, as the one I'm looking at right now, the box where your answer has to go has a percentage outside it. And if they wanted you to do the decimal answer, they would just give you the box without the percentage. So if you see the answer with a percentage over it, you know you're going to do the percentage. If you see the answer has to be written, but there's no mention of a percentage here, right, just relative frequency, then you know you're going to use the decimal instead. That makes sense? Now, if you take back to the original one, right, the frequency table, if you take that, you can make a diagram. And the diagram that you can make is called a bar chart. And let me show you how you would construct from scratch, very simply, what a bar chart looks like. So you have an X and a Y axis. And along the X axis, I'm going to do never. And that's going to be 3. What's the biggest number I need there? It's 1, 2. So 5, 10, 15, 20, 25, 30. Don't really need any more than that. And on this axis, the vertical axis, you always do the frequency. So never was 3 people, so that would be about there. You then leave a little space, and the next one was sometimes. I'm just going to put some because I don't have enough room to write sometimes, and that's going to climb to 15. And the next one is mostly. So you leave the same gap, and that climbs all the way up to 30. And then you leave a gap, and you put always, and that's just 2 people. And you make a little guy like that. This is called a bar chart. And God, you might have been, I know, 10 years old the first time you drew one, and that's what they are. You label that frequency. You label that with something like, have you ever broke the speed limit? That way, if someone reads this chart, they say, oh, mostly broke the speed limit, always break the speed limit, never broke the speed limit. And then they can say, oh, that's how many people it was. And that is called a bar chart. And some people who are more artistic than I am make them red, green, and blue, and all that stuff. So far, so good. Now, for something like that, it's probably easier just to do it by hand, right? Just do these percentages by hand and draw a little sketch of this. But how does that work on a computer software, right? You can't really show the screen what you did and hope that the web page is watching you. I mean, that doesn't make sense. That doesn't happen. So this is how WebAssign gets around that same issue. This is how it asks you the same questions. So their question that I'm doing is similar to it. This is wearing a seatbelt. So 100 people have never wear the seatbelt, 466 most of the time, another 1,400 always wear the seatbelt. So in this particular case, you see that number is a really awkward number. So won't that 2,525 go in the bottom, right? So if you want to define the percentage, that's the keyword, percentage, but you can tell it's a percentage because of that, of 12 grades, that's 12 grades that we're talking to here, always wear a seatbelt. You take that number, and you would divide it by the total, which is this number. And then wouldn't you multiply everything by 100? Wouldn't that be the calculation? that you would do, right? And you get what you get. And do you notice they say round off your answer to 2 decimal places? So I'm going to go and actually do that calculation. So on the top, it was 1428. On the bottom, it was 2,525. And if you multiply it by 100, you get 55.55 and a whole of the other stuff. So to 2 decimal places, you would write in 56.55. So that's kind of how you would do the calculation ones, right? Now there's a funny little button here. This is, I think, the first time we've ever dealt with it. I'm going to try it right now. Hit use salt. And hey, do you see it's uploaded that table with all the numbers? That's cool. And now we want to do stuff with it, don't we? So let's look at charts and graphs. And I would like to do a bar chart. The variable is going to be where's seatbelts. And look what they've done. And they've done a much neater version of what I did. Right? Now, if you can imagine that picture, because it's going to disappear in a second, right? Imagine that in your brain, right? You still see it. If I move this away and I scroll down here, can you see the one that looked like it was this one here? So if you did it by hand, you would look at your picture and say, yeah, the third one looks like mine, and you'd pick it that way. If you decided that you just want to let the software draw it, when you memorize this guy and say, okay, yep, that's the one I've got, pretty obvious, we got it correct. So isn't salt kind of, what's what I'm looking for? Isn't it helpful, right? Takes a little bit of the strain. Wonder what else salt might be able to do for us. So I'm going to click on this one again. There's the data. And we'll see if we've got anything here. Nothing here. Nope.
It helped me because I can look it up as a pie chart, and it helped me with the percent that way.
Oh, thank you for telling me that. I was looking for something that would help me with that. So we're looking at charts and pie charts, and we're seatbelts. And if you look really carefully, it's kind of awkward, but it's there. Can you see the 56.55, essentially? I mean, that's the decimal version, but isn't it easy to turn a decimal into a percentage? I mean, just multiply by 100. So that would be 55. Wouldn't that be 9.58? Wouldn't that be 11.45? Yeah, so that pie chart does that for you. I don't think it was designed to do that, but it's nice that it does, because it doesn't make your life quick. So there we go. Please clear that off. Right, now I'm going to kind of do this one. I might have to shrink it a little bit to get everything I want in one place. It's not going to be any better. Okay. In a survey, participants were asked, would you say that you are very happy, pretty happy, or not too happy? And the results were 671 people said very happy, 137 that one, 326 the next one. And here is our table that we should be filling in. So I'm just going to take these numbers. 671. The next group, 1,367. And the not too happies were 326. Now, if I wanted to get these percentages, if I needed to do it by hand, wouldn't I take that number and divide it by the total, which I'd have to calculate, and I'd do that by adding all these guys together, right? And I could get that, right? And then I could turn the percentage. But I'm going to see if we can use salt. right? There's all the data. That's cool. If I go into charts and we'll do the pie charts with response. Can you see this guy here is 57.83% for the pretty happies? Can you see the 28.38 for that one and the 13.79 for that one? So do you see that you could use the pie chart, which Cody discovered for us, to get those guys? If you want a percentages, just multiply each of these by 100. Now, if you wanted to get a bar chart, you click on that one, and here is your bar chart. So let's see what they got. Could we get the percentages from the pie chart? And although it's disappeared on us, one of these guys is the same as the one that I've just got, and I'm pretty sure it's that one. Now, in case you get too lazy, do you notice that this one does not have a salt line? Which means we can't do all those nice shortcuts. Isn't this one we're being forced to do it by hand? So let's set this one up. In a 2010 survey in a statistics class, they were asked, how do you prefer to use your cell phone, to talk with it or to just text? Of the 103 self-identified women, so that's the total that's going to go here, 29 said that they liked to talk, and 74 said they liked to text. Of the 86 self-identified males, 33 said they liked to talk, and 53 said they liked to text. So did you see I had to actually just read the story and put the numbers in where they went? Now, what one will I pick? Pick this one. For men, calculate the percentage who said they like to talk. So for the men, it was 33 out of a grand total of 86 of them. And I'm going to do that right now on my calculator. So if you do 33 divided by 86, they want the answer as a percentage and rounded off to 1 decimal place. So I'm multiplying by 100, and to 1 decimal place, it's 38.4. Now, what about women? How many of the women decided that they liked to talk is their main way of using it? Well, in their case, it would be 29 out of 103. So 29 out of 103, and the answer I get here is 28.2%. Now, can you see that we can now compare men and women in this situation? Would you agree that the evidence seems to be that men prefer to talk more often than the women do? Do you agree? Now, you couldn't come to that same conclusion quite as easily if you looked at what we call the raw data. And the reason for that is there's a lot more women that were being asked than men. So wouldn't that naturally make all the women's numbers bigger than all the men's numbers? Can you imagine if you asked 10 times more women than men? Wouldn't there be 10, would there be a lot more in every answer? Percentage-wise, could it men be bigger, but you wouldn't notice it because all you have is the raw data. So why we bother to do these relative frequencies, right, these percentages, is because doesn't that give us a like with like comparison, right? 40% of women, 20% of women, right? You can do any kind of comparison easily once you've done that. And then it asks you to write 1 or 2 sentences about what you think men and women and what the differences and or similarities would be. Now, in this next question, I think they went scarily big. Would you agree this table has got a lot of stuff in it? What they have here is combining, do you wear seatbelts with school grades? Now, I haven't bothered to look at the data, so I'm going to make a really big assumption. If you're dumb enough not to wear a seatbelt, you're probably dumb. So I'm going to make the assumption that people who don't wear seatbelts tend to have a higher percentage of D's and F's. Okay, that's my assumption. So let me see if I can put that into effect. I'm not even going to look at theirs. This is mine. Those who never wore a seatbelt, 16 out of 107, right, basically failed the class. So let's see what percentage of those kind of people would fail. So that would be 16 divided by 107, and I make that about 15%. So there's 15%. Now, the ones who always wear their seatbelt, 46 of those failed, which is actually a lot more than 16, would you agree? But there's a lot more of them. So let's compare it a fair way. 46 out of 1,407 of them ends up being 3%. Was my assumption that if you're dumb enough not to wear a seatbelt, you're probably just dumb? Isn't that kind of being reinforced by this data? Right. Now, though this is a little bit silly, they do actually use this type of data. Do you know that if you have a really good GPA, don't you get a better insurance rate? Have Margaret, are you nodding because it's happened to you, or you just know about it?
Yes, both.
Both of them, right? So you might say, well, why do they do that? Can you see that intelligent people tend to do sensible things, and maybe less intelligent people, and that's a really cruel way of describing anyone, but whatever, tend to do dumber things. And dumber things include not wearing seatbelts and maybe driving more quickly than they should, and all sorts of other things. And so insurance companies are aware of this, so that's why they do it. People with good GPAs just have less accidents than people who have low GPAs. Yeah, we've got time for one last question. This following table gives the age distribution for mothers in a certain country and when they had their first child. Right. So if we want to read this table, it's over 2 distinct years. So let's pretend it's Scotland. I know it's not, but just pretend, right? In 2006 in Scotland, 21.7% of them had their first baby when they were under 20. Right, so that's very young. At least in 2006. 35 and over, which is really quite old to have your first child, is 8.7%. But notice, not only do you that, do you see that there's a time difference? Isn't there a change? So over just what, a 12-year period, hasn't that figure halved? And wait a minute, hasn't this got even bigger? Now, people who deal with social scientists, this is the kind of data that they love, because what it's telling us, things have changed. And how they changed? People are probably getting married later and having their first child later. And that's true all the way up, isn't it, virtually? Even to that age. That is a reflection of this particular country's societal changes. And now you've got evidence. You can't just say, well, you know, I think this is what's happening, right? That's not really proof of anything. You would say, this is why I believe what I just said is happening, right? And the explanations could go there. Well, while we're here, I'll share a story. As you know, I'm coming from a very large family. This is a fun story in our family. My mum had her last baby when she was 49. And while my mum was in hospital having her first baby, my brother Billy's wife was having her first baby. So my mum was having a baby while her daughter-in-law was having a baby. So when those babies were born, that baby was born an aunt. Can you imagine a baby being an aunt? Which she was. I think that's kind of fun. Okay, take attendance now. For your attendance, will you remember it's only your last name I want, right? So I don't want your full name. So Cody, you just put in Laney for example, right? So in the chat box, put down your last name, and that's what I'm using to do attendance. Anybody here want to share? Has anybody here an aunt to somebody that's younger than them? What you got, Maggie?
Yeah, I was born an aunt.
You were born an aunt. Cool. So the person you're born an aunt to, she doesn't call you Aunt Maggie, does she?
No, we don't even talk.
Okay. I don't know why that's the case. Anybody else born an uncle or an aunt?
My uncle is 3 years younger than me.
Cheyenne, what about you?
Not me, but my daughter, my oldest, is actually 3 years older than her aunt, and my youngest is within 3 months of her aunt.
So it's not that uncommon. It's kind of fun, isn't it? I don't know why I think it's fun, but it does. It must be great when you have parties and you say, "Here's my uncle," and he's this kid at 6. That just to me strikes my funny bone. Okay, someone said I don't tell jokes, so I'm going to tell you a very quick joke because I want to. So, you ready for this one? They are really corny, I should warn you. Which one shall I use? Why don't you play cards in the jungle? There's too many cheetahs. Okay, bye-bye, guys. I will see you tomorrow.
I have a question on one of the homework assignments.
Okay, River. Which question was it?
It's one of the questions about the explanatory and respond variable.
Okay.
It's number 12. It's about the, I don't know if we have the same problems.
This one we will have the same problem for. So
okay.
I can put this one on the screen. You can we'll talk through it because there is a good chance that I may disagree with the answer that the book has. So that might be your problem too. So was it A and or B? Which one was causing the trouble?
Yeah, kind of both of them.
Okay. So to answer the following questions, researchers would measure 2 variables for each individual unit in the study. Well, that makes sense. In each case, specify the 2 variables, what kind of variable, right, what their type is, and then whether it's an explanatory variable or a response one. Okay, so for college students, is a relationship between their GPA, so one of the data was, I got a 3.2, I got a 1.7, and the second one is the number of hours that they spent studying, right? So it's GPA, hours studying. So in my case, I would say the explanatory variable, right, is the number of hours that they study. And the number of hours you study is a number, so it's quantitative.
Yeah.
And the response variable in this case would be the individual student's GPA. And the GPA, I would also say it's a number, right? It's a, well,
Yeah.
rewind up. We do numbers, but in some colleges you get an A or a B plus or a C, you know that?
Yeah, letters.
Right, so I'm assuming it's a number, so I'm going that way. Now, did you do that?
Yeah, I think that's.
And did it say it was wrong?
I haven't clicked submit because.
Oh, you get 5. You get 5 shots. So if it's not right, you can, you've still 4 more. It won't do
Does
any
it also
damage.
count for 5 shots if the 4 answers though? Because there's 8 questions.
Yeah, but no. One
okay.
one hit is just 1 shot.
Oh.
Okay, so you want to do
Yeah,
it
that was
just to convince me that we're on the right track here. Because if we're not, I want to figure out why
Okay, yeah, I got that right.
Okay, so next one then, individuals United States fall into one of a small number of tax brackets based on their level of income. Is there a relationship between a person's tax bracket and the percentage of income donated to charity? So I'm just going to go for the order. So the explanatory variable is their tax bracket.
Tax bracket, okay.
And a tax bracket is like A, B, C's and things. So I'm taking a tax
Really?
bracket as a category, right? Because it's not a single number, it's a range of numbers. And the
Okay.
response variable then is
The percentage of income.
the percentage of their income that they do. Now that is a number, isn't it? 2.1% or something. And
Yeah,
since
that's
that is a
one.
number, I'm going to go quantitative.
Okay.
Right, you want to hit that one and we'll see if we get that one.
Yep. Oh no, it's categorical was wrong.
So they are saying that there is a number. Okay. Well, click it one more time because there's only one thing that was wrong, so it shouldn't take long to fix.
That was still wrong.
Oh,
So I guess it's ordinal.
because it goes up, of course. Ordinal. It is categorical, but
Ah, yeah, that is it.
yeah, you have nothing to 50, 50 to 1,000, 1,000 to 20.